Okay, people, breaking news. This is the greatest rhombus problem you will ever see. Okay, like I just said, we got a rhombus here. That means we got all 8 properties of a rhombus. You have to know your properties of a rhombus inside and out, and especially know how the diagonals within a rhombus create all sorts of triangles. I count 8 altogether. And what's the goal? The goal is to find x. We got a few x's everywhere. We got x's here and here and here and here. And the other thing we want to find is the perimeter. We're going to check out the perimeter at the very end of this rhombus. So I do notice right from the start that this is a segment and this is a segment. I do not believe they are equal because I know those two blue segments right here are congruent, and those two green, the two green ones are congruent. So I'm not quite sure how to set up an equation to find x using those segments. Let's take a look at the angles. The angles, I have an expression for 3x plus 40, and I have another expression for this angle down here at 7x plus 10. Well, somehow these two angles are related, and we are going to be able to write an equation using those two expressions. Well, if you know the properties of a rhombus inside and out, you should know that this angle is also 3x plus 40. Why? Because the diagonals bisect each other, bisect each angle. And also, these two angles are also 3x plus 40 as well. It's because opposite angles are equal. And like I just said, the angles the diagonals bisect each angle. So, in other words, I can rewrite an expression for that angle down below, that is 3x plus 40. Well, somehow these two angles are connected. And how are they connected? Well, think about how the diagonals interact with one another. You have to have it in your bloodstream that the diagonals are perpendicular. Well, how is that going to help? Well, if you really focus on this triangle now, ask yourself, how does 7x plus 10 and 3x plus 40 relate? Well, that's right, they are complementary angles. So what is the equation I can write? 7x plus 10 plus 3x plus 40 equals 90 degrees. And we can solve for x in here. So that looks like 10x equals, that's 50, over there that's 40, x turns out to be 4. Okay, so we're halfway there, we get x to be 4. So now, how are we going to find the perimeter? Well, let's take a look at these expressions about these segments within the diagonal. So this one over here was 2x, this one over here was 3x. So if I use my value of x to be 4, this side over here is going to be 12. This segment over here is going to be 8. That does mean that this segment is 8 and that segment is 12. And how is that going to help us find the perimeter? Well, it turns out all 4 sides, excuse me, I didn't want to use x. It turns out all 4 sides of the rhombus are congruent. So if you take your eye onto any one of these triangles, the yellow triangle, the blue triangle, the beige triangle, the green triangle, it doesn't really matter which one we use, because if you look carefully, all those triangles are congruent, and we know 2 out of the 3 sides. And if you notice, not only do we know 2 out of the 3 sides, every single one of those triangles are right triangles. So we have another equation we can write. 8 squared plus 12 squared equals w squared. And so let's use a little Pythagoras in here. We got 64 plus 144 equals w squared. Let's scroll down a little bit. 64 plus 144 when I went to school was 208. And so what are some factors of 208 that are perfect squares? I think I got it. W is the square root of 208, and if I if I simplify the square root of 208, that is radical 16 times radical 13, otherwise known as 4 radical 13. So This side over here is 4 radical 13. That is the length of one side of the perimeter. Well, how would I, excuse me, yeah, it's the length of one side of the rhombus. So how would I find the perimeter? Well, I'm going to take 4 radical 13 and times it by 4 because there are 4 congruent sides. So what is my final answer? 16 radical 13. That is the perimeter of this rhombus. So I hope you learned something, and we'll see you soon.